Okay. We're recording. All right, open up Rhino. See that right there? Do something like that. Remember when we did the Boolean, the axon? We'll do the axon next week. Okay. What's the first thing we need to do when we open Rhino, just to reiterate? Units. Hey, Daniel. How's it going? Oh, boy. Inches. I like inches. Feet in inches. And I like a 16th of an inch precision. All right. Here we go. We'll do a save as. Week 5, Boolean. Okay, so our assignment is to begin with a 6-inch by 6-inch cube. How do we model a cube? There's like 100 ways to do it, but what's the most basic way? I recommend here, does everybody see this icon there? These are your solid tools. These are your volumes. So if you hold this down, you see all your solid shapes. And then even under box, corner to corner, and height, there's also, I can define it diagonally. I can define it with 3 points and the height. Let's try that. So let's draw here. Turn on my ortho. I'm draw this way 6 inches. 6 inches. 6 inches. Is everyone able to do that? See that? And I like, this is generally my favorite color. Generally, not just in this class. All right, so we've got our cube. If I measure it, 6 inches. All right, I'm going to copy and paste this a few times to show you to illustrate some of the different Boolean operations that exist. And I'm going to go through those quickly. So what we want to do, I think the assignment sheet says you need to, using no less than 6 geometric primitives per Jessica's suggestion, but 6 objects, 6 solids. So you can't Boolean with a surface. You need to Boolean, you need to overlap and intersect volumes. And then you're going to be solving one in relation to the other. So let's start with the sphere. All right, so my first sphere, I'm going to attach to this corner. I'm going to do it arbitrarily. Okay, I've got this. And I want to copy and paste this just to illustrate the different commands. Okay? So our first command we're going to try is Boolean. And by the way, we can type these, or you see these two overlapping spheres? Everybody look here. See this right here? If I hold that down, I get all these options. So, let's try these 4. Okay? So Boolean union, let's try that. Select surfaces or polysurfaces to union. This one and this one. Click enter. Okay, look. Now what has happened is it has trimmed out the overlapping portion, and this is now a single volume. We do like poly surfaces and poly lines. It's a continuous line made up of individual sections. This is now a single surface, single volume, I should say. So they're merged, effectively. We union them. Let's click here. Let's try the second one. Boolean difference. Select this surface or polysurface to subtract from. We'll do both options in reverse order. So let's subtract from this one. Click enter. Surface to subtract with. Click enter. Okay? Let's do it again and select them in a different order. Let's subtract from this one using this one. See that? And then last, we can do 2 more. Let's do Boolean intersection. See that? And now I should be able to take this. So, for instance, you may want to, 3D print each of these out of different materials, or fabricate them out of different materials and have them fit together like a type of inlay. And then let's do one last one. The last Boolean is Boolean splits. See that? So it has now split this surface or this solid using this. So if I hide this one, you'll see that it's left a separate piece, right? So they interlock. So play around with those, guys. I would say for this assignment, we're primarily going to stick with Boolean union. So let's try that. So we have our 6-inch cube. I'm going to take an internal pole. All right, we're going to do a sphere, model a sphere. So it intersects. I recommend like snapping to the corners. And you just need these things to overlap. Okay, Jessica, what's your favorite shape? Cones. Triangles? Three-dimensional, you like a pyramid or a cone? What? Pyramid? All right, let's go here. Anybody see the pyramid there? So look, a pyramid, you tell it how many sides does the base have. You like a 3-sided pyramid? They don't have it. I clicked on number of sides, and then I typed 3. Here's 9. We'll do 3. Okay? Chris, what's your favorite shape? This is being recorded. Another pyramid. How about a cone? Here's a cone. I'm going to rotate this cone. You know what? I'll just leave it. It's fine. You yawning. What's your name? What's your name? Bailey. That's right. What's your favorite shape? Look at all these options. How about ellipsoid? Ellipsoids are pretty cool. There we go. And turn on my mid point. I'm going to snap down here. Look at the ellipsoid. What? What is this called? The donut geometric is called a torus. Like a Ford Taurus. Ford Taurus is spelled A-U-R. Alright, so look. The only issue we may have with this move it down a little bit. How many shapes do we have here? Only 5. Oh, we got 5. We need one more. Let's do another sphere. No, let's do a different shape. Let's do a cylinder. Okay? Let's see what this turns into. So we're going to try Boolean difference. We want to subtract from the cyan colored one. We want to use this one, this one, this one, this one, this one. The donut is kind of messing it up. Let's try this. Let's move the donuts. They're a little too big. Let's move them out a little so they're not subtracting so much. All right, let's try it again. It's a little nicer. So I think the best part about Boolean operations are like you get these unexpected intersections between shapes. And to illustrate this point, if I were to, and again, you are free to use spheres if you want, or use, they don't all have to be different shapes. Let's try this. Boolean difference. Select the cube, select all the spheres. It's kind of nice, isn't it? Okay, so it's up to you how you want to do it. Maybe play around with it, try to get something particular. I mean, it can be just a kind of random chance operation like this, or you may want to try to, do something like that. You also could think about, structurally, if you wanted this to resemble like a vaulted structure or something, then you may want to try something like actually, this would be a great place to do an ellipsoid. Let's do an ellipsoid. How can I make this wider? I can type scale 1D. Origin point is here. First reference point is here. And look, see how I'm doing that? Then I could do it in the opposite direction as well. All right, for instance, I want to show you this. So this is kind of like a vaulted structure. See that? These become like vaults and columns. And see how these touch here to like open into one another? It's kind of a nice feature. Anyway, so, maybe decide what you want to do. This is perfectly fine. The next part of let's go with this one for now. Copy this down. Okay, we're here. So the next part of the exercise is to slice it. So if we want to prep this for laser cutting, it states that to laser cut, you're to slice 6 sections through the model and lay it out, and lay out the sections as a waffle system for assembly, complete with notches. You must cut at least 6 sections, 3 in each direction. Okay? So we remember how to do that from the last exercise. You guys see this? I don't like this frame. I'd rather this be at the base. So I can select it and type move and just click from here to here. from here to here. Okay. So what I'm going to do now, I'm going to look at it in the top view. Okay, I want to slice this thing. So I'm just going to arbitrarily and randomly place 6 sections. Do one there, do one here, and do one here. Okay? So you see I have this grid over this. So one way I can do this, let's do it 2 ways. One way is I can project these curves onto the surface, right? So let's try that. Project. Curves and points to project, this one and this one. Enter, project it onto this. And now if I look in 3D, I've got these projected on there. Do you see that? So what I can do now is hide this object. And look, my ribs are there. My sections are there. Now I can take these and I can type planar surface. Planar surface. Planar surface. Pretty fast. Pretty quick and easy, right? So I can make these red. And then if I unhide the exterior, so I've got red ribs. So it's a little bit like the last exercise, a bit more complex in terms of the structures. But you see it here. I'm going to pause. All right, so we have this and this. And, you know, listen, depending on the complexity and size of these things, you know, we probably could unroll these surfaces and laser cut them and glue them together. But if you were to build something bigger, you would want like an internal structure to support it. So what we want to do for Monday is take this, I'm going to delete the grid lines. We don't really need those anymore. Alright, so to fabricate the ribs, we need to intersect them and notch out the intersections. And then to fabricate this, we need to just unfold it. So I'm going to first explode it. Let's see now each face is a separate face. Alright? What's the challenge going to be here? Challenge is going to be unfolding this. Remember the problem of unfolding the sphere? That's why there are so many different versions of the map of Earth. They're called globe projections. Remember the Mercator projection? You know, you get these things. So you can split it like that. You can split it like that. This is kind of a weird one. Since for Valentine's Day. Look at these. It's a challenge, but generally spheres are not flat surfaces. Buckminster-Fuller came up with the, what was the Buckminster-Fuller one? You got octahedral, tetrahedral, icosahedral, cubical. But it's a challenge. There's a little bit of a challenge to this. And if you look at Buckminster-Fuller came up with this one. Who's Buckminster-Fuller? See, this is his. That's basically correct. This is his. I have seen it in person. There's only 2 of them. With that Maxine car. Why am I on Etsy? I don't want to be on Etsy. See, there's his map. And it folds up like that. Yeah? But ultimately what he's showing and what you have to accept is that, you know, this is obviously a representation of something that is spherical using flat faces. So even that amount, the curvature is missing from that, but it's abstracted flat in planes and in faces. So we're going to have a hard time unfolding this. I would like you to go through the process of trying to do this. So take the skin. Let's take the skin. And let's hide the ribs for now. So you know how to unroll the ribs and laser cut them and slot them together. So do that, and I'm happy to go over that again if you want in this video. But I would say hide them for now, and then I want you to go through the process of unfolding this. So what command do we use to unfold? We can type unroll, and it will do that thing, but in this case, we're going to manually just do it ourselves. All right? So to do it, we're going to select everything. And then we're going to deselect whatever piece we want to just leave. Let me get rid of these two. Okay, so there's our surface. I'm going to start by rotating the top. I'm going to select it. I'm going to do rotate 3D. I'm going to click here, here, and here. Okay, so I open the lid on the box. Now, a few options for doing that are that I could click this and this. You have to make some decisions when you start doing this of what you want to leave connected. So for instance, I could do that. You can see the problem that we're going to have. But again, I kind of want you to experience the problem. So now let's select this and this and this. And maybe we'll take this one too. And maybe this side piece. And this piece. Okay? And we're going to 3D rotate that. See what we're doing? Now I'm going to take this and this. And I'm going to 3D rotate that flat. You want to have ortho turned on while you're doing this. Oh, sorry, I selected the wrong one. Take this and this. Okay, next I'm going to take this one. I'm going to take this whole thing because it's only attached here. And you'll see as you do it, as you lay it down, you want to make sure like one edge is still connected to something. Like this is going to be a challenge, this piece, because it's not connected to anything except the, these things, which are going to be somewhat inaccurate. But we'll try. So maybe we just rotate that one flat and disconnect it. I'm going to separate that. All right, you see this guy over here, that's a little bit of a problem. Where'd that one come from? It's often hard to see him. So look, this, and this. We can easily just duplicate the curves. So we could type dupe border, duplicate the border. And look, we get, these lines. Right, and if we explode these lines and get rid of the overlapping, because they were duplicates, get rid of the duplicates. And now we can make all these cut lines. And then the lines in between, I recommend you use cyan and red, and let's make these red and dashed. And then these will represent the fold lines. So it'll cut out this entire perimeter, and then we fold along the dashed lines, right? Or you can use your own scallop line type, whatever it is. And so, but we know that here we need to attach this thing. So try to unroll these. Type unroll surface. It says unrolling doubly curved surfaces will produce inaccurate results. If you want to unroll it anyway, try using the smash command or adjust the relative tolerance on the unroll surface command line. So let's try that again. Unroll surface. I don't see a relative tolerance setting. So let's try a smash. What's that? Relative tolerance. Let's do 1. Where's my origin? It did it. Look at that. Okay, so this turned to this. How? Oh, I think I see it now. It looks like it maybe scaled it in the process. So one thing I could do is measure this length. So I could duplicate an edge. Type dup edge. And I can duplicate that edge. And now I can, if I type list, it shows me the length is 4.26. So what I could do now is take this and draw a line 4.26 and then scale this. Does it look right? Not really. Kind of. So you see you're going to have to curve this line around that edge. You're going to be trying to doubly curve a flat surface, which is going to be nearly impossible. In fact, it is impossible, but you're going to smash it on there, and you're going to see what happens. Let's try the smash command one more time. So if we type smash, linear direction, natural, let's see what happens. Explode. Let's do labels. Let's do labels. Let's do it both ways. So we'll explode it. I'll do it again. So there's smash. And this is useful because, look, it shows which edges are which. Yeah, so you see this 2 edge is this 2 edge. Looks like it shrank it again. So you may have to scale. Generally, when you unroll things, you need to check the scale and just make sure it's correct. So looks like we have a similar issue. But look, at least here we can see that this 3 is this 3. There's a 0 and a 1, and then this is 4 over here. So we may want to like flip this thing over and then rotate it this way. Okay, so you can kind of see how we're getting that. And try it. I would like to see you try to smash them. We clicked explode on that one, right? Let's try smash again. I thought we clicked yes. Let's click yes. Yeah, I think it doesn't actually explode it. All right. So there you see it. So what I would like you to do is then, so we can take this, we're going to need to scale it. So we know that that length, what was that length if we type list? 4.26. So let's type a line 4.26 and scale this correctly. Okay, so that should be scaled correctly. What happened? Let me check something. So if I duplicate this edge, so I'm going to type dupe edge, and I'm going to do it over here too. So if I type list, scroll down, it should give me a length. It doesn't give me a length. Three and a quarter inches. Now let's try this one. 4.5 inches. So it didn't, you can see it, it stretched one dimension for some strange reason. I'm not quite sure. But you know, you're going to have a hard time fitting 4.5 inches of material into 3 1/4 inches of space. So but anyway, guys, do your best. So what I recommend is to build this. So fabricate the ribs, and if you want me to quickly go over the rib model again, I'm happy to do that. But ultimately, I feel what you're going to get is something like this. So at least the flat sections you should be able to construct. And then these pieces may be missing. Does that make sense? So I'll get the sides, and then you'll see that these are really approximated by a lot of straight sections. And that is a command, you know, kind of generally referred to as sectioning or contouring. Okay, so I took the side, and I drew some lines, and I can type project again. I can project these curves onto that surface. And then look, I get something like this. Yeah. And now I could take these curves, and they're flat because they're projections. So I projected flat lines. So even though they're curves, I can lay them down flat. I could laser cut each one of these, and I could take this, for instance, and slice, you know, small ribs that would fill in this face. I did something wrong. See that? So I could easily cut these ribs, and I could notch them into that structure, and that would give me a kind of close approximation of that surface. You see that? So there are ways of taking complex surfaces through slicing, you know, sort of giving enough information in order for it to be read. And then I could always take these, and I could, like, you know, extrude, curve. You know, so I could make this like 1/8 of an inch. And if I did that for each one, I do extrude curve, I select distance, so I'm just going to draw it straight out, and then I do 1/8 of an inch. Yeah, so for instance, I could cut a bunch of ribs like that to fill them in, and they sit on top of this support structure behind it. Does that make sense? Yeah. I could also, I probably actually would want to extrude them the opposite direction. I want to extrude them towards the ribs so that they overlap. Right, and so then I could notch them out and fit them in. Okay? You see the weird taper here? It's because I'm extruding them in ortho. A better option is probably to offset them. So I could take each one, offset, let's say a 1/2 inch. And then I could loft. Okay? And you'll get like a uniform thickness of curve. Everybody see that? So I can do that for each one of these. So see that? So there are enough ways of, like, through slicing, of filling in enough information to do something like that. All right? There's a good example of a woodworker I like, named Matthias Pleisnig. Look what he does. See what he does? So he cuts sections using sectioning. He basically fabricates ribs, and then he steam bends wood and bends them over, a lot like boat building. But if really that is a line that he's snapping the points and clamping in place, doing something like that. You see? Traditional woodworking that seems to be a kind of digital way of modeling things. So is everybody clear on this? Do you want me to intersect the ribs again and go through that? You want to just look at the last demo for